Hello everyone, this is Adnan, and in this lesson we will be talking about the concept of yield. So yield in a chemical equation where there are three types. One of them is theoretical yield. What is a theoretical yield? Let's take a look at the balanced equation. So for example, nitrogen gas, 1 mole of nitrogen gas is reacting with 3 moles of hydrogen gas to produce 2 moles of ammonia. This is a balanced chemical equation. So we can simply say that the yield, a theoretical yield, is 2 moles when 1 mole of nitrogen gas is reacting with 3 moles of hydrogen gas. So the yield of the product that we are getting is 2 moles, right? So simply, what is a theoretical yield? It is the amount in moles or mass in grams of a product that is obtained according to the balanced chemical equation, right? So let's say if I change the moles of one of these. So let's say I have 2 moles of nitrogen, for example, right? So what will be the yield of ammonia now? So since the mole ratio is 1 to 2, so it will be 2 to 4, right? So 1 mole of nitrogen is producing 2 moles of ammonia. So if the question says that 2 moles of nitrogen are reacting with excess hydrogen, so then the yield produced of ammonia will be doubled, right? 4 moles. So this is basically what a theoretical yield is. So now, what is actual yield? Actual yield is when we perform this experiment in a lab, and what we get in reality, that is that is actual yield. So actual yield, we can say that it is always experimental. And the other thing that you need to remember about actual yield is that it is always going to be always less than the theoretical yield. There can be many reasons for this. We are not going into that detail. Just remember that, or actual yield is always less than the theoretical yield. Okay, so I mean there can be measurement errors. The reactants may not react completely. There may be a byproduct that is being produced which we are ignoring, so some mass gets transferred to that. So there can be many reasons for this, but just remember that actual yield is always less than the theoretical. So the third type of yield, it's basically the percentage yield. It's the ratio. So percentage yield is actual yield divided by the theoretical times 100. So you have to memorize this formula. If for some exam boards they give us this formula, for some exam boards they don't give you this equation. So it's better to be on the safe side. You should memorize this formula. So now let's see what type of questions we may get from on the exam. So I have this question. Let me just paste it quickly on the whiteboard, and let's solve it. Okay, so here we go. Magnesium reacts with oxygen to form magnesium oxide. A student reacts 12 grams of magnesium with excess oxygen. The actual yield of magnesium oxide obtained is 18.5 grams. Calculate the percentage yield of magnesium oxide. Okay, so one of the problems one of the the confusions the students they worry about, or that they make mistake, is that they are unable to find, or they are unable to identify which one is theoretical yield and which one is actual yield, or how to find a theoretical yield. So this word, the actual yield, may not be given to you in the question. The question may read, a student reacts 12 grams of magnesium with excess oxygen, and 18.5 grams of magnesium oxide was produced. calculate the percentage yield of magnesium oxide. So remember that what is given in the chemical equation, this will be the actual yield, and you will have to find the theoretical yield yourself. So let us solve this question. We have been given the mass, in grams. So we have to convert it into moles. So the molar mass is given of magnesium, which is 24. So to find moles of magnesium, I'm going to divide 12 over 24, and I get 0.5. So we have 0.5 moles of magnesium, that we are working with. Okay, so now I'm gonna check that, what will be the theoretical yield. How do I check that? How do I calculate the theoretical yield? I can see that the mole ratio is 2 to 1 to 1 or 2 to 2. So 2 moles of magnesium, they are reacting with excess oxygen, and they're producing 2 moles of magnesium oxide. So if I have 0.5 moles of magnesium, so 0.5 moles of magnesium oxide will also be produced. So you just have to cross multiply, and so 0.5 times 2 divided by 2, you're going to get 0.5 moles of magnesium oxide. Okay, so now this is my theoretical yield. So this is 2 is not theoretical yield. Remember that, right? Because we are not reacting 2 moles of magnesium. We are reacting 0.5 moles of magnesium. This is where you have to pay attention. Now that we have our theoretical yield, now we can convert this into moles. Uh, the yield, the actual yield that we are getting. So okay, so yeah, so no, I think we have to keep it like that, because we have to, uh, yeah, since it's a percentage yield, so it doesn't matter if we can take in if we use grams or moles. So let's see. So for 18.5. Okay, I'm going to calculate the molar mass of magnesium oxide. So it's 24 plus 16, we get 40. So 18.5 divided by 40. So I'm going to get 0.46 moles, right? Okay, so and you see, we the actual theoretical yield is 0.5 moles, and the actual that I converted from 18.5 to moles, so I got 0.46 moles, right? So we can see that this is the actual yield is less than the theoretical. So now I'm going to put this into the formula. So actual yield is 0.46 and divided by, and 0.5, which is theoretical, and I'm going to I'm going to multiply that by 100. So 0.46 divided by 0.5, so I get 0.92, and when I multiply that by 100, I get 92%. So 92% is the percentage yield. So this is basically how we calculate the yield, percentage yield, right? So let us solve another question now. And okay, I'm going to convert this into mass, and let's see if I can get the same answer. So instead of moles, I'm going to use mass for both the actual and theoretical yield. So 0.46 times 40. So this will give me the mass of magnesium oxide. So 0.46 times 40. So that's 18.4, which is given in the question as well. So, and 0.5 times 40. So I get 20. Yeah, so I think it will be the same. So 18 more. So 18.4, which is actual, divided by 20, which is theoretical, times 100. So this is gonna give us 18.4 divided by 20. Yeah, again, 0.92 times, yeah, so 92%. Yeah, so you can see that, you can also calculate it in moles while keeping it in moles, or you can convert it into grams, but it doesn't matter, it gives you the same answer. Okay, so now let's make it a bit more complex. So I'm sharing this second question with you. So sometimes the questions on yield, they can be made a bit complex by changing the mass or moles of both the reactants. So when that happens, you will have to find the limiting reactant first, because let's say if you're using excess reactant, the moles of excess reactant to find the yield of a product, so you will get an artificially higher yield, which will not be the case, and your answer will be incorrect. So let us take a look at this one. Now let's read this question, which says that aluminum reacts with chlorine gas to form aluminum chloride. The balanced equation is given, and the question says that a student reacts 0.60 moles of aluminum with 0.75 moles of chlorine gas, and the actual yield of aluminum chloride obtained is 52 grams. Calculate the percentage yield of aluminum chloride. So the relative atomic masses are also given. Okay, so now you can see that in the statement, the moles of both the reactants, they have been changed, right? So in our lecture on limiting reactant, which I've linked above, so if you don't understand the concept of limiting reactant, you can watch that video and then come back here. So we have to find, since the moles of both the reactants are changed, so we have to find the limiting reactant first, because the limiting reactant is the one that reacts completely, and it controls the yield or the amount of the product produced. So in order to find the limiting reactant, let's compare the moles. So we have 2 moles of aluminum from the balanced equation reacting with 3 moles of chlorine. So it's 2 moles to 3 moles. And now we have 0.6 moles of aluminum. So and this will be X, because I'm cross-checking this. 0.75 moles are given in the question. I want to cross-check that whether I need more or less than 0.75. So when I cross multiply 0.6 times 3 divided by 2, I get 0.9. So now I'm going to compare. Yeah, so 0.75, which is given to me in the question, 0.75 moles of chlorine gas are given in the question, which is less than what is actually required, which I just calculated, 0.9 moles, right? So this is basically chlorine is our limiting reactant, because it's going to get consumed first, which because we don't have enough of this. And the other reactant, aluminum is our limiting, our excess reactant, right? So now I'm going to use the mole ratio of chlorine in order to calculate the theoretical yield of aluminum trichloride. So the mole ratios from the balanced equation are 3 to 2, 3 ratio 2. So now if we have 0.75, so what will be the theoretical yield of aluminum chloride produced? So I'm going to cross multiply. So this is going to be 0.75 times 2, and that's 1.5, and I divide that by 3. So I get 0.5 moles, right? Okay, so this is the theoretical yield now. So the actual yield, which is given in the question, which is in 52 grams. So now I can either convert the moles into mass, or here this mass into moles, because we just saw that it doesn't matter whether you take it in grams or moles, you will get the same answer. So let's convert this into mass, right? So 0.5 moles times what will be the molar mass of aluminum trichloride? It is 27 plus 35.5 times 3. So this is 106.5 plus 27. So we get 160.5. So this is the molar mass of aluminum trichloride. So 0.5 times 160.5. That's going to give us 80.25 grams. So this is basically the theoretical yield, which I just converted from moles to mass. So now we can use our equation, which is actual yield over the theoretical yield. So this is going to be 52. So yeah, you can see that it has to be less than the theoretical yield. If it is greater than the theoretical yield, so it means, or your theoretical yield is, let's say, greater than the actual yield, then there may be something wrong with the question, right? So 52 divided by 80, which is theoretical 80.25 times 100. So 52 divided by 80.25, this is 0.64 times 100, so we get 64.7%, right? So that's the answer. And yeah, so just remember that if the moles of both the reactants are changed, so you must identify the limiting reactant first, and using the mole ratio of the limiting reactant, you must calculate your theoretical yield. Okay, so this will be all for this topic. And if you need private tutoring sessions, so you can fill the form, Google form, which is given in the description, and I'll contact you. I'll see you in the next one. Thank you.